Hello. Today we're going to talk about section 7.6 parabolas. This corresponds to Abeka pre-algebra, page 329. So hopefully you'll recall what linear equations are. Linear equations have only a single variable, and the exponents are always 1 for those variables. So if I have the equation y equals 3x plus 2 and I want to evaluate whether or not it's linear, I ask, well, do I only have one variable? And yes, I do. And is the exponent on that variable 1? Yes, it is. If you don't see the exponent, then it is 1. So this is a linear equation. Now, if I'm looking at y equals 3x plus 2x plus 3 plus 5, I have 3x and I have 2x. Well, those are like terms. So I can go ahead and evaluate those. If I have 3 apples and 2 more apples, I have 5 apples. So if I have 3 x's and 2 more x's, I have 5x plus 3 and 5 are both constants, so I can go ahead and evaluate them. 5x plus 8. Well, now with my simplified expression, I can see I still only have a single variable, x, and the exponent on that single variable is a 1. You don't see anything, so it's 1. So this too is a linear equation. In this next example, y equals 3x plus 2m plus 3 plus 5. Well, I can simplify it to some degree. I can go 3x plus 2m plus 8, but I'm still stuck with 2 variables, 2 different variables. I cannot combine those terms. They're not similar. They're not the same. So I have 2 different kinds of variables. I don't even have to look at exponents at this point. I know it's not a linear equation. So no, it's not. Now y equals x squared in this last example. Well, I'm back to a example where I only have one variable. So now I need to look at the exponent. And that exponent is a 2, which is greater than 1. So this too is not a linear equation. Now, hopefully you remember a linear equation, if you were to graph it, you would get a straight line. And hopefully, and when I say graph it, I mean like on the Cartesian plane, that the xy axis, where the x axis is the horizontal part and the y axis is the vertical, and they intersect at the origin. All right, so that's the Cartesian plane. When I am graphing on the Cartesian plane a linear equation, I can just graph 2 points because the 2 points are needed for a straight line. Now the book did recommend graphing 3 points just for accuracy, but technically 2 points are needed, are all that's needed for a linear equation. Not so with nonlinear equations. Now, if a linear equation graphs out to be a line, a nonlinear equation does not graph out to be a line. So a nonlinear equation might be this. It might be a circle, or it might be something called a parabola. That's a parabola. Looks like a U, or it could be an upside down U, like that, parabola. You need more than 3 points to graph a nonlinear equation, and for parabolas, you need at least 5 points. Parabolas need 5 points to graph. A parabola can be graphed from an equation, and the equation will look like this. Y equals ax squared plus bx plus c, where a, b, and c are all constants. So we only have one variable, the x, but one of the x's has a 2 exponent and the other has a 1. So it's not linear because of that fact of the exponents. So the thing to keep in mind for parabolas, number one, is their shape. Parabolas will open up like that. Parabolas can open down like that. Parabolas can go sideways like that or reverse. So that's a parabola. The other thing to remember is that you need 5 points to graph it. So if I have y equals x squared minus 6x plus 10, and I am asked to graph it, I need to go ahead and create a table of my xy values. I can go ahead and fill in x values and then plug those values into the equation to get my y value. So 1 squared minus 6 times 1 plus 10 is going to be 1 minus 6 plus 10, which gets me 5. Then I'll plug 2 into it, and I'll get 2 squared minus 6 times 2 plus 10, which is 4 minus 12 plus 10, a positive 2. Then I put a 3 in, and I would get, I'm not going to write any more out. So hopefully you can see that 3 squared minus 6 times 3 plus 10 would be 9 minus 18 plus 10, which would get me a 1. And then 4 squared, which would be 16, minus 6 times 4, 24, plus 10 is going to get me 2. And then 5 squared, 25, minus 5 times 6 is 30, plus 10 would get me 5. So that the hard work's done. Now all we need to do is graph it. So you draw your Cartesian plane, your xy axis. 1, 2, 3, 4, 5. One, 2, 3, 4, 5, 6. All right. So my first set of points is 1 and a 5. So I go over to 1 on the x-axis, and then I go up to 5 on the y. 1, 2, 3, 4, 5. My next ordered pair is 2, 2. So I go over to 2 on the x-axis and up to 2 on the y, and I make my point. My next ordered pair is 3, 1. So I go over to 3 on the x-axis up to 1 and make my point. My next ordered pair is 4, 2. So I go over to 4 on the x-axis and up to 2 and make my point. And finally 5, 5. I go over to 5 on the x-axis and up to 5. And it's about there. Then I just connect the dots. And obviously, given how shaky my hand is, this is not very good. And the fact that my lines aren't perfectly straight and everything, but I end up with a parabola, which we could have known just looking at the form of the original equation, x squared minus 6x plus 10 would graph as a parabola because it looks like this format, ax squared plus bx plus c. These numbers, the a, b, and c are the constants. So the a in this equation that we just graphed was a 1. The b is the constant that's in front of the x with an exponent of 1. And so the b has a value of 6 in the second equation, and the c has a value of 10. All right, that is 7.6. Good luck with the work.